All right, section 5.7 continued again. We're still seeing this flipping the sense of the inequality, reversing the sense of the inequality going on. So one way we could do this to prevent reversing the inequality is to make sure that our x remains positive. To do that in this example, you'll see that we would have to add a 2x to both sides. And this is going to make this problem like 3 times longer than it has to be in order to keep this variable positive. So now we're going to see that 5 is greater than 9 plus 2x. And then we'll have to move the constants over to the left. And now we see that negative 14, that's not negative 14, that's a negative 4. A negative 4 is greater than a positive 2x, so negative 4 is greater than 2x, and then we multiply by the reciprocal. That number is not negative, so this is not flipping the inequality, right? So negative 2 over here, and then greater than or equal to an x. And then we want this to read so that we see the variable on the left and the number on the right, and then the inequality points to the x, so still pointed to the x, and now we can read it easily. So we are going to locate our endpoint, negative 2, and it's less than that, and so we're going to use a right parenthesis, and then we're going to go off to the left. And then interval notation, what we have on the left, which is negative infinity, never include it, and then up to negative 2, and it doesn't get included either. Now that's how we would do it without trying to do the flipping the sense of the inequality. So we're going to do exactly the same process by using the idea of reversing the sense of the inequality. So this time around, I'm just going to do what I would normally do, move the number away from the variable, because I'm not going to worry about making the variable's numeric coefficient positive. So I get negative 2x is greater than 4. And now here's where I have to be careful, because here I need to multiply or divide by a negative number. This is the thing that flips the inequality. So when I do that, I now have not a greater than, but a less than. And so now I have that x is less than a negative 2. And you see that this solution is exactly what we got here when we wrote this in standard form. And you see, all the flip of the inequality does is it reads this inequality answer backward for us. And so that's what flipping the sense of the inequality, or reversing the sense of the inequality, is all about. And we actually need to learn that skill, because when we go to solve a compound linear inequality, we don't have a choice in that. So let's go ahead and take a look at solving some compound linear inequalities. Actually, I've changed my mind. Instead of doing the compound inequalities, let's save that for the next video, and let's go ahead and solve this example number 42 in case you've done that one. If you haven't, pause, do it, and then check your answer. So this simple inequality, this doesn't require us to do any reverse of the sense of the inequalities or anything. So first of all, we're going to combine the like terms here. So we have 5x, and then we have a minus 13 is less than or equal to, and then 15, and then plus 3x. And so then our next step is to move the variables together. So we'll just move them over here to the left. That both keeps them positive, and we'll put this in standard form, both good things. So 5 minus 3x, which is going to give us 2x, minus 13 is less than or equal to 15, and then add the 13 to both sides. And so that'll give us 2x is less than or equal to 28, and then we multiply by the reciprocal there and there, so we get x is less than or equal to 14. And then we'll go and graph that. Okay, so now that we have the solution, we're going to go find our endpoint. I've done this one by 2s so that I could get it fit on here. So here's my 14, that's 12, and that's 14. It is included, it's going off to the left, so I'll use a right bracket on the endpoint and the arrow off to the left. Last but not least, interval notation. Left we go to negative infinity, comma, up to positive 14, and 14 is included, so I use a bracket on it. And there we go.